When you think of ice cream, there's one name that stands out above the rest: Ben & Jerry's. It's not just the delicious creamy texture or the wild fun flavors that keep people coming back for more. It's the brand's commitment to quality, creativity and social responsibility. But have you ever wondered how the magic happens behind the scenes? How do those quirky flavors like cherry Garcia and fish food come together in that iconic pint? In today's video, we're taking you on a sweet journey through the history and the step-by-step process of how Ben & Jerry's ice cream is made in their factory. The story of Ben & Jerry's begins in 1978 in a small town called Burlington, Vermont. Two childhood friends, Ben Cohen and Jerry Greenfield, decided to take a leap of faith and start their own ice cream business. The pair originally thought about opening a bagel shop, but when they realized the cost of equipment, they pivoted and took a $5 correspondence course on ice cream making with an initial investment of just $112. A combination of their own savings and a loan from Ben's father. The two friends opened their first scoop shop in an old gas station in downtown Burlington. Their mission was simple: to create the creamiest, most flavorful ice cream imaginable. In those early days, they handcrafted each batch of ice cream using just a few basic ingredients: cream, milk, sugar, and a healthy dose of creativity. The business quickly gained a loyal following, and in 1980 they began packaging their ice cream for grocery stores, changing the way people enjoyed frozen treats. From Chunky Monkey to American Dream, their pints have become a global sensation. But how does all this creamy goodness actually come to life in the factory? Let's find out. First off, it all begins with the foundation of the ice cream. The dairy Ben & Jerry's boasts of using only the best, responsibly sourced ingredients. They partner with family farms in Vermont and the surrounding areas to guarantee that the milk and cream used are of the highest quality. The process starts with mixing the milk and cream in huge mixers known as mix tanks. The ratio of milk, cream and other ingredients is carefully determined to guarantee that every batch is flawless. The secret to a decadent Ben & Jerry's flavor is the dairy, sugar intractable added to measure to that signature smoothness. Next, the blend is pasteurized. This is simply heated to a boiling point to kill off bad bacteria, making sure the ice cream is safe for eating. It also breaks down the fat cells in the cream so it mixes together more evenly for that rich, creamy texture we all love. Pasteurization also plays a role in the flavor. The higher temperature allows the sugars and dairy fats to caramelize slightly, enhancing the base flavor of the ice cream. After that, the mixture is rapidly cooled to around 48 degrees F to prepare for the next steps. The dairy base is blended with vanilla or chocolate or whatever the core flavor of the ice cream is. For example, when making chocolate fudge brownie, a rich cocoa powder and chocolate syrup are added to the mix. It's all about balancing the right flavors to create the perfect foundation. Ben & Jerry doesn't stop at just the flavor base. This is where the real fun begins. The mix ends. You can't have a pint of Ben & Jerry's without those decadent chunks and swirls. Cookie dough, fudge brownie bits, caramel swirls and so much more get added at this stage. The key here is the size and distribution of the mix-ins. Ben & Jerry's is famous for packing in generous chunks, so every spoonful is a perfect bite. Once everything is blended together, the ice cream mixture is ready for freezing. But it's not just put into a freezer and left to freeze. Instead, the ice cream is transferred into machines called batch freezers. These machines churn the ice cream while freezing it, which is very important to achieve that smooth, creamy texture. Churning while freeing aids in producing minuscule air bubbles within the ice cream, giving it that trademark light, airy texture. This process is called overrun, and Ben & Jerry's ensures the right amount of air is whipped into the ice cream. Not too dull, not too fluffy, so the ice cream is now perfectly frozen and churned, ready for packaging. Now this part isn't easy by a mile as it sounds. Ben & Jerry takes great care in how the ice cream is packed into pints. Each pint is filled to exactly the right level and the ice cream is smoothed out so it stays fresh and looks great on the shelf. Here's where the magic happens: the swirls and chunks. Ben & Jerry's doesn't just mix the chunks into the ice cream base, they swirl them in at the end to give you that perfect bite every time. Once the pints are filled and the mix-ins are added, the pints are sealed with a lid and sent down the production line, but the journey's not over yet. The pins now go into a deep freeze to harden up and reach the ideal temperature for scooping. The ice cream spends several hours in a blast freezer which cools it down rapidly. This helps it retain that smooth texture and prevents the formation of ice crystals which could impact the richness after it is held at a stable freezing temperature until it is to be shipped out to grocery stores and ice cream fans around the world. From Vermont to your grocery store, it's a journey that begins with fresh local ingredients and ends with you enjoying a scrumptious pint of ice cream. And that's how Ben & Jerry's ice cream is made, from farm to freezer to your home. It's a process that takes precision, passion, and a lot of care to create the perfect pint. And of course it's all about fun flavors, creative mix-ins, and a whole lot of love. Hey there syrup lovers, did you know that the maple syrup industry in North America produces around 3.5 million gallons of syrup every year? That's a lot of maple goodness, but here's the thing, making that syrup is no easy feat. It takes a precise combination of nature, tradition, and technology to create that golden sweet liquid we all know and love. So how about exactly as maple syrup made? Well, let's take a deep dive into the process, but before we jump in, don't forget to hit that like button and subscribe for more sweet content. Let's begin where all the magic starts, tapping the trees in early spring. When the temperatures start to fluctuate between freezing nights and warm days, the sap in sugar maple trees begins to flow. But how do we get that sap out? Well, we need to tap the trees. Tapping is done by drilling a small hole in the tree trunk and inserting a metal spout called a tap. These taps are usually connected to buckets or modern tubing systems that run between trees to collect the sap. The sap is mostly water with just a little bit of sugar in it, about 2 to 3%. And it takes a lot of sap to make just 1 gallon of syrup. In fact, it takes about 40 gallons of sap to make just 1 gallon of pure maple syrup. After the trees are tapped, the sap begins to flow. But how does it get from the trees to the sugar shack where the real magic happens? Well, nature does most of the work here. The freezing nights and warming days cause pressure changes inside the tree that cause the sap to rise up through the trunk and out of the tap. This process can last for a few weeks. During the early spring, when the conditions are just right, the sap flows best on days when the temperature is above freezing but the nights are still cold. This temperature fluctuation causes pressure to build up inside the tree, forcing the sap out. Once the sap has been collected, it's time to move it to the next stage, harvesting the sap. In a traditional maple syrup operation, this involves gathering buckets filled with sap and transporting them to a storage tank. In more modern systems, tubing is used to transport the sap directly to a central location. Once the sap is in the tank, it's ready for the next big step, concentrating. Fresh maple sap is mostly water and it takes a lot of sap to make syrup. So before we can begin boiling, we need to concentrate that sap in order to save time and energy. And a reverse osmosis. Reverse osmosis is a process in which the sap is filtered through membranes that separate the water from the sugar. By pushing the sap through these special filters under pressure, we can remove a lot of water content before it even hits the evaporator. This makes the next step, evaporation, much faster and more energy efficient. This saves a lot of time and wood, which is good for the environment and for the syrup makers. Bottom line, now we're getting to the good stuff, evaporation. After reverse osmosis has done its job, we take the concentrated sap and boil it down in a giant evaporator. The evaporator is an industrial-sized pan that sits over a fire or a propane burner. The goal here is simple: get rid of as much water as possible until the sap becomes thick enough to be syrup. As the sap boils, it changes, the water evaporates, and the syrup slowly starts to take shape, changing color and becoming more concentrated. This is a delicate process because we need to boil the sap to exactly the right consistency and temperature. The syrup is done when it reaches about 219 degrees F 104 degrees C. At that point, the sap has reached about 66% sugar content and the liquid is thick enough to be called syrup. But boiling it to the proper temperature isn't about syrup production. It also draws out flavor. That's where the Maillard reaction is important. This is a reaction that occurs when sugars and amino acids in the sap are present and heated. This is what gives syrup that rich, complex flavor and its darker color. As the sap boils, the sugars within the sap break down and caramelize, creating those delicious caramel and butterscotch flavors we love. The longer the sap boils, the darker and richer the syrup becomes, which is why late season syrup has that bold, robust flavor. So next time you pour syrup over your pancakes, you can think the Maillard reaction for all that deep caramel goodness. After the syrup is ready, it's filtered or one last time to remove any final impurities, and then it's poured into bottles or jars. From here it's ready to be labeled, packaged and shipped out to stores all over the world. And that's it from tree to table. The journey of maple syrup is a sweet one that requires precision, skill and a little bit of magic from both nature and technology. Imagine the sun-kissed fields where vibrant raspberries ripen, their sweet tangy scent filling the air. Now picture that fresh fruit transforming into the delicious spread we all know and love, raspberry jam. In today's video we're going to take you all the way through from farm to factory, how raspberry jam is made from picking up the berries on the farm till that jar is sealed to go out and be distributed to stores. We will examine each step of that, and let's get some likes and hit the subscription channel if you want more like it. We get behind the scenes stuff around common everyday foods. Before we dive into the factory, let's talk about where the jam making begins. Raspberries are a delicate fruit requiring specific conditions to thrive. They grow best in cooler climates with long mild summers and well-drained soil. Regions like Oregon in the US and the United Kingdom are famous for their high-quality raspberries. Here they flourish, soaking in the sun and rain to produce plump, juicy berries perfect for jam making. Raspberry bushes are carefully tended to throughout the growing season, ensuring the best possible fruit. Unlike others fruits, raspberries are perishable, and hence it has to be hand-picked. Laborers in the farm have to fast but very gentle not to smash the fruits at the picking time. The best berries are usually those that are riper as well as plump, along with its deep red color meaning peak flavor. Once picked, they will be carried gently into boxes or a container ready for transported to the manufacturing facility. Once the raspberries reach the factory, they are unloaded and channeled into an initial sort. This process is very critical. Only the best is used to manufacture jam. Separation process of the overripe or overripe ones and those that are damaged. Some use latest technology machines to distinguish the products from impurities. Some still depend on human labor when checking the produced quality. Subsequent to this are the washing of the raspberries to expel dirt as well as debris, pesticides. They are put into big washing vats where soft jets of water make sure every berry is cleaned properly without getting damaged. It's crucial that the berries remain in one piece, as their shape and texture will determine the final product. Once cleaned, the raspberries are now ready for the next stage, crushing. In most modern factories, the berries are passed through a crusher or pea. This machine breaks the fruit down into a puree which will be the base of our jam. The pulp is collected and taken into large cooking kettles. Here the raspberry puree is mixed with sugar, which helps preserve the fruit and gives the jam its signature sweetness. The amount of sugar varies based on the desired sweetness and consistency of the final product, but a typical ratio is around 60% fruit and 40% sugar. As the mixture begins to cook, it's carefully monitored to prevent burning or overcooking. The cooking process can take anywhere from 20 minutes to an hour depending on the scale of production and the type of equipment being used. During this time, the pectin in the raspberries is released, helping the jam thicken and take on that perfect spreadable texture. Temperature control is critical at this stage. The jam must reach a precise temperature, typically around 228 degrees 104 degrees C, to ensure it sets correctly. Some factories use advanced technology to measure the temperature and consistency, while others use the spoon test, a straightforward procedure whereby a small quantity of jam is dropped onto a spoon and allowed to cool to determine if it has the right thickness. Once the jam has reached the perfect consistency, it's time for jarring. The hot jam is carefully poured into sterilized jars in large factories. This process is automated with machines that fill and seal hundreds of jars every minute. Music. However, quality control remains. This point has all the jars inspected for bubbles or imperfections and seal ensure jam remains fresh for as long as possible. Once filled, seal on the jars with lids fit tightly to prevent any air to leak into. Some factories apply techniques through the use of vacuum seals draws the air out of the jam before sealing to increase its shelf life to ensure the safety and edibility of the jam. To make it safe for consumption, has a long shelf life. It's pasteurized. This means the sealed jars are heated to a specific temperature for a set amount of time to kill any harmful bacteria or microorganisms. Pasteurization also helps preserve the color, flavor, and nutrients of the jam. After pasteurization, the jars are moved to a cooling station where they are allowed to cool down gradually. Once cooled, the jars are transferred to the labeling station. Here, each jar is carefully labeled with its product name, ingredients, expiration date, and branding. The labeling process is usually mechanized in big factories, but the design and application of the labels are checked carefully for accuracy. Lastly, the jars of jam are placed into cartons ready to be shipped out to distributors, stores, and directly to customers. The packaging ensures that the jam stays secure and intact during its journey from the factory to your local grocery store. After all the hard work and care put into the production process, your jar of raspberry jam finally makes its way to your home. Whether it's for a morning breakfast spread, a sweet addition to desserts, or an ingredient in homemade pastries, raspberry jam is the perfect way to enjoy the taste of summer all year round. From the fields to the factory and finally to your table, the journey of raspberry jam is a testament to the hard work and care that goes into producing every jar. Next time you spread that delicious jam on your toast, you'll know exactly how it got there. If you bite into a scoop of plum beer, you'll be hit with flavor so rich, creamy, and smooth that it practically melts on your tongue. This iconic Russian ice cream has been a favorite for generations. Even more impressive, a single factory can produce thousands of these treats in just 1 hour, with each lot prepared with care and precision. So how does a basic blend of ingredients end up being such a popular sweet treat? But first, some background on its origins. Although plum beer has become a Russian favorite, its origins date back to 19th century France. A French confectioner from Plumerlines was the first to create this sweet treat by mixing fruits doused in cherry liqueur and eggs and cream, freezing it. That delicious treat eventually made its way to Russia, where it evolved into the plum beer that we know today. In Russia during the Soviet era, plum beer became a must-have dessert. The Soviet government set strict standards known as G, requiring plum beer to be made with high fat content and no artificial additives. These rules ensure that every soup was rich, creamy, and full of flavor, helping plum beer become one of the country's most cherished treats. The process of making plum beer starts with gathering the best ingredients. The main components include fresh milk, cream, sugar, eggs, and sometimes condensed milk. Factories typically source their milk and cream from local dairies that focus on quality and sustainability. The cream's high fat content is crucial because it gives plum beer its rich and creamy texture. Sugar and condensed milk are added to sweeten the mixture and make it smooth. The white eggs act as a natural emulsifier, helping to blend everything into a silky mix. Once these top quality ingredients are chosen, they are taken to the factory where the magic takes place. The first stage in the factory is mixing. Large industrial mixes are used to combine all the ingredients into a smooth, uniform liquid. This stage is critical as any inconsistency in mixing could lead to uneven texture or taste in the final product. Once all the ingredients are mixed together, the next stage is pasteurization, that is heating the mixture to about 85 degrees C to kill any harmful bacteria. Pasteurization is really important because it makes sure the ice cream is safe to eat and helps the flavors blend well, but it's a delicate process. If the mixture gets too hot, it can change the flavor. If it's not hot enough, harmful bacteria might survive. After pasteurization, the mixture goes through homogenization, which is the key to making plum beer so creamy. Homogenization is where fat molecules are divided up into minute droplets and dissolved throughout the mixture. This is done through a device that subjects the mix to high pressure. By doing this, the fat remains thoroughly mixed in, so that ice cream is smooth in texture with no lumps. If this step is not done correctly, then ice cream may end up oily or lumpy, which would not taste so great. Once the mixture has been homogenized, it's then transferred to the aging tanks where it rests and thickens for several hours. Usually between 4 to 12 hours aging is important. because it lets the flavors fully develop and the texture get smoother. During this time the proteins and fats in the mix work together to make the ice cream creamier. The tanks are kept cool around 48 degrees C so the mixture thickens slowly without freezing. This aging process also helps make sure the ice cream will hold up well during freezing. It's a simple step but it's key to giving Plombier its rich dense texture that people love after the mixture has aged. It's time for freezing and churning. This is where Plombier really starts to take shape. The aged mixture is put into a continuous freezer, a machine that churns and freezes the ice cream at the same time. Churning is important because add a good air mass that impregnates the mixture, resulting on a smooth and not porous end product. Plombier only a little mass is added, resulting into the dense and the rich texture as it compares with the ice cream. The continuous freezer also reaches freezing point, and again in the case of being frequently agitated, it smoothens and remains creamy because it does not obtain massive crystal ice. It very swiftly brings down the ice cream temperature to about under 28 degrees C. The speed that ice cream is concurrently frozen. Freezing is crucial to maintain the smooth texture and avoid any graininess. By the end of this process the Plombier has assumed its final form, but it's not yet ready to eat just yet. Now that the Plombier is perfectly frozen and churned, the next step is shaping and filling. Depending on the final product, whether it's a tub, cone or bar, the ice cream is carefully shaped and packaged. If the Plombier is destined to become ice cream bars, the mixture is poured into molds to take shape and then harden further. For tubs or cones, precise filling machines dispense just the right amount of ice cream into each container. This part of the process is highly automated to ensure everything is done with accuracy and cleanliness. The machines are designed to be incredibly precise, making sure every package has the correct amount of ice cream with no waste. Once the ice cream is filled, it's quickly sent to a blast freezer to get the final hardening touch. The blast freezer works by blowing super cold air at high speeds over the ice cream, making sure it freezes evenly and quickly. Once the Plombier has hardened, it's ready for packaging. The packaging process is also fully automated to make sure it's done efficiently and hygienically. The ice cream is moved along conveyor belts, going through various stages of packaging. For bars, this might mean wrapping them in paper or foil. For tubs, the ice cream is placed in containers which are then sealed with airtight lids. The packaging is designed to keep the ice cream fresh and protect it during transport. Sealed packages are important because they prevent freezer burn, which can ruin the texture and flavor of the ice cream throughout the entire production process. Strict quality control measures are in place at different points along the production line. There are inspection stations to check for any defects or inconsistencies. Advanced technology like X-ray machines and spectroscopy is used to spot any contaminants or irregularities that might not be visible to the naked eye. Each batch is also sampled and tested for texture, flavor and consistency to make sure it meets the high standards expected of Plombier. Only after passing these tests does the ice cream move on to storage and distribution. Once it is packaged, the Plombier ice cream is stored in cold storage rooms where the temperature is carefully controlled to ensure the ice cream is maintained perfectly until it is set out for shipment. These storage rooms kept at around 25 degrees C to ensure the ice cream remains frozen and fresh. Finally, the ice cream is loaded onto refrigerated trucks for distribution. These trucks are designed specially to maintain the low temperatures required to maintain ice cream frozen while being transported. Transporting frozen products is a challenging endeavor, and these trucks are fitted with GPS and temperature control gauges to ensure that the ice cream reaches its destination in the most optimal condition. And there you have it, the captivating journey of how Plombier, one of Russia's most popular ice creams, is prepared in a factory. From picking the best ingredients through the meticulous processes of mixing, pasteurizing, homogenizing and freezing, every step is Intended to make a rich, creamy and utterly delicious product, the history of Plombier is as rich as the ice cream itself, evolving from a French dessert into a Russian classic that's loved by generations. Their production process blends tradition with modern technology, ensuring that each batch of Plombier meets the highest quality standards. Whether it's in a cone, tub or an ice cream bar, Plombier is more than just a dessert. It's a taste of history and a testament to the art of ice cream making. If you enjoyed this dive into ice cream production as much as we did, click on the next video for more behind the scenes looks at how your favorite products are made.